A natural extension to the two-level directory is tree structured directory. It is not tree structured directory. So it is the extension to the two-level directory. So what happened with two-level directory is you are going to have a master directory and then a directory for each user. But the problem with that organization is, what if user has a user has lot of interrelated data files. For example, a user wants to put all the source programs in one directory and all the executable files in one directory, all the songs in one directory and movies in one directory. If that is the case, then there is no way he could group the related files together in a two-level directory. So just for that reason, we are going to extend the concept of two-level directory to the this one, tree structure directory. Now what is the tree structure directory is, we are going to have something called as the root directory, and after the root directory you can have any number of levels. So let us say at the first level you can maintain user level directories. Let us say this directory belongs to user 1. This is the root directory. See, we are not talking about any particular operating system. We are not talking about Linux or Windows or anything. Therefore, whatever I discuss here is about the concept, not the implementation, not the case studies. So even though there is a name called root directory in Linux, that is not what we are talking about. Yes, that is an implementation, right? So it is in general I am talking about it. So if any operating system wants to implement a tree level directory, it can go like this. So it can have a root level directory and then user level directories, and a user can have may want to group many directories to many files together and put them in one directory. For example, he might want to put all the source programs in one directory. Let us say the directory is named as source programs. Similarly, he might want to put all the executable programs in one directory and he might want to name it as binaries, right? And similarly, he might want to put all the songs in one directory and he might name it as songs, right? And now coming to these binary programs, there might be various projects. Let us say he wants to have all the programs related to some project 1 in one directory and all the programs related to project 2 in other directory, right? And now finally there can be files in the directory like this, or there can be files in the directory like this. So now if you see this, earlier if you look at the two-level structure, it is just a tree of height 2, isn't it? But here the height of the tree can vary, right? Which means, see, height of a tree can vary in the sense, what I mean to say is, a file can be found at any level. For example, this root directory itself can directly contain a file, or the user directory itself can directly contain a file, or the user level can contain some, user level directory can contain some other subdirectory, and that subdirectory may contain a file. Therefore, files can be found at any level. Now, how are you going to specify, if you want to access any file? How are you going to specify it? Earlier, if you want to access a file, how are you going to specify it? It is simply username followed by the file name is going to give you the file. But here it is not that case. A file can be present anywhere, right? Therefore, you are supposed to specify the path at which a file can be present. Let us say there is a file called as binary1, b1.exe. This is the file you wanted to execute. Now how can you specify it? So for that reason we are going to use something called as the path name of the file. So what is the path name here? You are going to start from the root, and inside the root there is a directory called as u1, user1, and inside the user1 there is a directory called as binary bin, and then project1, right? And then b1.exe. This is called as the path name. Now there are two ways you can specify the path name. One is called as absolute path name and the other one is called as relative path name, right? Absolute path name and the other one is called as relative path name. What do I mean by absolute is you are actually specifying everything. You are not leaving anything to chance. You are specifying everything right from the root to the file. Then that is called as absolute path name. And the other way of specifying it is using the relative path name. Now what is the relative path name is we are specifying the name of the file in relation with something else. So how is that being done here is whenever any user logs in, the operating system is going to assign in a local variable something called as present working directory or current directory, some variable. So depending on the implementation the names may change, but every operating system is supposed to give or supposed to assign this particular variable for every user when he logs in. Let us assume that when user 1 logs in, the present working directory given to the user 1 is u1. Now present working directory is of the user 1 is root/u1. Now if that is the case, if root/u1 is already present in the present working directory, then any process that is started by this user need not specify these two if it wants to open a file, if it wants to open this file, right? So if you specify everything from here to here, from starting to ending, if you specify everything, that is called as absolute path name. If you don't specify this part, and if you specify only from here to here, then this particular part is understood, or it will be taken from the present working directory variable and it will be added to this, and the search will be done. In that case it is called as relative path name. If you don't specify everything, that is called as relative. If you specify everything, that is called absolute. Now as and when a user logs in, the operating system is going to assign this particular variable, and any process that runs on behalf of this user or any process that is started by this user will get this present working directory as default. And in case if this particular process spans a new process, then the sub process, if it is going to use the fork system call and then creating a new process, then the new process is also going to use the same present working directory, right? And now some operating systems will also give the flexibility to the user to change his present working directory. For example, by using some system calls, he can specify that present working directory is not u1. He might say that present working directory is u2, in case if he is allowed to do so. So every directory and file will have certain permissions which are called as read, write, execute permissions, and in case if a user is going to have a read permission on some directory, then he can change the directory and read those directories files. And similarly, if he is having execute permission, then he can change the directory to that particular directory and then execute some file. For example, a user, if he is having execute read, write, execute permissions both to u1 directory as well as u2 directory, then even though when he logs in initially onto the system, if he gets u1 as the present working directory, he can change it to u2. Now after he changes to u2, then he can whenever he tries to access any file, then the relative path will be converted to the absolute path by using this one as the prefix, like this, root/u2. So what is the flexibility that that we get here by using the tree structure is, one thing is user has the ability to group all the files together, and also users have the ability to share a directory or a file with other users, right, by changing that path. And what are the other advantages or disadvantages you see here is, one disadvantage is traversing might not be so easy, right? If you have only one level directory or two level directory, implementation is straightforward, or it is not as complex as the tree. But here when you have to traverse or when you have to find a file, then it is not that easy. You might have to traverse the entire tree in order to find a file, right? So now we shall see how to share a file without actually giving the permissions, or how to now we shall see something called as graphs. There I'll show you how in practice the sharing of files is being done. Here also sharing of files is being done using permissions. Now we can see one more method using which we can get this tree into a cyclic graph. I'll show you that later. Okay.